On the 1st of August 2026, OpenAI announced that an unreleased model had solved 10 open problems in mathematics, problems that had resisted their fields for a decade at minimum, and in most cases far longer. The number that traveled fastest was the price, $2,000. That number is real. It is sourced, and it is missing something, and the person who pointed that out works at OpenAI. Let me start with what is not in dispute, because it is genuinely impressive, and because almost every argument about this release skips straight past it. 10 results spanning 8 areas of mathematics and theoretical computer science. They include a disproof of a long-standing conjecture in operator algebras, the construction of a non-sofic group which had been open since the late 1990s, and the resolution of 3 numbered problems from Erdos. These are not warm-up exercises. Several of them settle questions that specialists have been circling for decades. And they were produced by a model called Astra, which OpenAI described as its next major model, and which nobody outside the company can use. Here's the part that deserves more credit than it is getting. Every single result ships with a lien certificate, a machine-checkable proof object. Anyone with a compiler and no trust in OpenAI whatsoever can verify it. That matters, because the standing objection to AI mathematics has never been that models produce unimpressive arguments. It is that they produce arguments which are plausible and wrong in a form that is expensive for humans to audit. A compiler does not find an argument plausible. There is one real limit. A certificate proves the formal statement follows from the axioms. It does not prove the formal statement is the theorem anyone actually cared about. That step stays human, but it removes the largest doubt, and OpenAI shipped it rather than just asserting correctness. Now the number. OpenAI said the tokens needed would cost roughly $2,000 at Sol API rates. Read that carefully. Sol, not Astra. Astra has no public pricing because it has not shipped. So this is a counterfactual what the token volume would have cost had it been billed at some other model's rates. No such amount changed hands. Divide by 10 and you get about $200 per solved problem, and that is the figure quietly doing the work in most of the coverage. And then 29 minutes later, in the same thread, the same researcher posted this, quote, "And yes, we did try other major problems without success. Sadly, no Millennium Prize problems yet, but also we didn't spend a lot on each problem. Read those two posts together and the economics change completely. The $2,000 is the cost of the 10 attempts that worked. The attempts that did not work are not in it. That is not a cost per result. It is a cost per success published without the success rate, a numerator with the denominator withheld. And I want to be precise about the credit here. This is not a critic's inference. Noam Brown volunteered the failures, unprompted, in public half an hour after the cost tweet. OpenAI was more candid in its own coverage. The first post made headlines. The second one mostly did not. Since the success rate is unknown, the honest move is to show how the answer moves with it. Every row here is arithmetic, not evidence. None of them is a claim about what OpenAI's real hit rate was. If the model succeeds every time, it is $200 a result. At 1 in 10, it is $2,000. At 1 in 100, it is $20,000. And notice which way Brown's own qualifier cuts. He said they didn't spend a lot on each problem. That suggests the per attempt cost is low because the attempts were shallow, not because the model is efficient. A deeper search would raise the cost per attempt, while presumably raising the hit rate. So the published figure is best read as a lower bound on cost and a lower bound on capability at the same time. Best frame for all of this was published before the thing it describes. In July 2025, Terence Tao argued that evaluating AI on mathematics needs standardized measures of both reliability and efficiency per unit of cognitive labor. His analogy was aviation, which reports cost per seat mile and the accident rate. That is exactly the shape of the problem. OpenAI published the cost per seat mile and withheld the accident rate. An efficiency number without a reliability number is not an evaluation. It is half of one, and it is the flattering half. 6 months later, Tao went further, flagging the strong reporting bias against negative results in precisely this domain, and noting that on the Erdos problem, set the true success rate is only a point or two, concentrated at the easy end. Both of those predate this announcement. Neither was written about it. They fit uncomfortably well. But here's where this argument usually stops, and where it should not. The sharpest version of the skeptical case is that you could run 100 expensive sessions and publish the one that worked. As a description of what is possible, that is unanswerable. Nothing in the release excludes it. Run the numbers on it, though, and the conclusion inverts. 100 failures plus 10 successes still land somewhere near $20,000 per major open problem. That is below the fully loaded annual cost of a single postdoc in any serious mathematics department, and no postdoc U is going to disprove a rigidity conjecture that had stood for decades. So the economic claim survives its own worst case. What does not survive is the precision. $2,000 is a specific number carrying an unknown multiplier, and the multiplier could be 1, or it could be 100. Which brings me to the part of this release I actually find most interesting, and which has been treated as an appendix. Alongside the proofs, OpenAI published a companion volume narrating how each argument came together, and a substantial fraction of it is about approaches that did not work. Those are real section titles. 8 of the 12 chapters contain a named dedicated account of a failed route, and these are not passing mentions of false starts. One of them develops a construction for a page and a half, establishes its properties, shows the whole conjecture would follow from one clean inequality, and only then explains why the approach cannot deliver. The heading calls that route useful, and on the document's own account it is, the failure is what proves the missing piece is a genuinely high-dimensional counting problem, and that is what licenses the change of setting that follows. Read across all 12 chapters, and the same narrative shape occurs with real regularity. An approach that ought to work gets pursued until it produces a precise diagnosis of its own failure. That diagnosis names the missing structure, and the resolution comes from changing the ambient setting, so the missing structure is there for free. In one chapter, the obstacle is that a theorem supplies many expanding components where the argument needs exactly one. In another, the problem was never finding two algebras that match. It was asking what a crossed product actually remembers. Different fields, same move. That is a claim about how the thing searches, and it cuts against both camps. It cuts against the brute force reading, because a system that just enumerated known techniques until something type-checked would not produce these diagnoses. But it cuts equally against the alien genius reading, because every move in the document is legible. These are known instruments, recombined by something with unusually broad recall, and no fatigue and no sunk cost bias. Tao has the right vocabulary for this, and again he coined it beforehand. He calls it artificial general cleverness rather than intelligence, solving broad classes of problems by ad hoc, fallible means that succeed at non-trivial rates when coupled to strong verification. Every clause of that describes this release, including the last one, and there's one limit worth stating plainly. These are the dead ends inside the runs that succeeded. We are reading the search behavior of the winners only. So what would actually move this forward? 4 things, none of which requires trusting anybody. First, an independent audit of whether those public lean statements match the informal theorems that needs no cooperation from OpenAI at all, and it is the fastest signal available. Second, a negative results list. It costs OpenAI nothing. It would stop thousands of researchers reattempting conjectures the company already knows this method does not crack, and it would convert $2,000 from a marketing number into an evaluation. Third, digestion by the actual specialists, which takes months. And fourth, reproduction by an outside party, currently impossible and the only one entirely within OpenAI's gift. So that is the brief. The proofs are very likely correct. The significance is unestablished. The economics are unknown. Those 3 can all be true at once, and most of the argument online consists of people asserting one of them as if it settled the other 2. If you want the sourced version, with every quote linked, it is at 10proofs.novitog.us.com. And if the useful part of this for you was the method spotting the missing denominator, separating the checkable claim from the marketing number, that is the thing we do every week inside the Hidden State Drift Mastermind. It is $105 a month. It is for practitioners rather than spectators, and the whole premise is stop learning and start building. HiddenStateDrift.com. Thanks for watching.